Welcome, and it's a new unit, Unit 3. We're talking about exponents and radicals. So that's what we're looking at in this whole unit. We're going to get into some complex numbers and imaginary numbers, a whole bunch of stuff way down the line. But I love where this unit starts with just our basic properties of exponents. So this is really meant to recall some information, hopefully from your past, and give you some resources as we move forward. Our warm-up is a really nice one, which one doesn't belong. And this is our fun game we play where something doesn't belong for some reason, and it could be lots of different, each one has a reason why it doesn't fit with the rest. So there you go. As you look through these, maybe you're noticing a couple things that don't belong and why. Maybe you're noticing part C doesn't have any exponents, if that's what this is all about. I notice this one has no exponents. And we could certainly rewrite that so it has it. We know exponents are just repeated multiplication. So I see this is 2 multiplying by itself 4 times over. So we could rewrite that as 2 to the 4th power that equals 16. And maybe I noticed that b has the exponent on the right side of the equation instead of on the left. So that might be something that doesn't belong for part b, that the exponent is on the right. We know that, of course, an equal sign means that either one could be on either side, so we could also rewrite that one. A doesn't belong because it's wrong. Maybe you saw that. Ooh, let's spell that right. Some days it's like that. This is wrong. 2 to the 3rd power does not equal 9. That would be 3 to the 2nd power that equals 9, because we saw that down here, that 3 times 3 is 9. 2 to the 3rd power is 2 times 2, which is 4, times a third 2, which makes it 8. And D doesn't belong because it's the only one that's got a variable instead of all numbers. So moving on, section 1.2 asks us to name that power, name the value in each variable that would make the equation true, and be prepared to explain your reasoning. This is putting into action rules of exponents from your past, but maybe you need a refresher about those rules. What I love about this is they have given us those exact rules here in the lesson summary. So I think this is page 8 of your workbook. In my classes, we put a big giant star on this whole section. And we're going to come back and use some of this blank space to write other rules. We're going to add more to it. But these are the rules about exponents that help us know what we're going to do if we're multiplying two bases. What we do if we have an exponent raised to another exponent. What if we're dividing two exponents with their bases? What if we have a negative exponent or a 0? Or two different bases, but the same exponent, how can we combine those together? So we're going to use these rules to help us finish section 1.2. So if you see me going back and forth, I'm just referencing which rule we look at. Our first one, we have the same two bases. I should say that first, that this is the base part, and then we raise it to an exponent. So if I keep on talking about a base, that's what I mean. It's the big number, and then the exponent's the little number up above. So I have the same base. Sorry about that. Two exponents, and our first rule tells us that as long as they're multiplying, we're going to add their two exponents together. So this one would be 2 to the 3 plus 5. Oops, I wrote the answer instead of 5. Some days are like this. 2 to the 3 plus 5, and of course 3 plus 5 is 8. And so 2 to the a power, a single exponent would be a would equal 8. Our next one has the same thing, same base and multiplying. So we're going to add those exponents. So b plus 7 has to equal this exponent 3 because these are all big. Gosh, I'm having a day. I'm sorry. They all have a base of 3, but it needs to equal 11 because the exponent is 11. If I subtract 7 from both sides, 11 minus 7 is 4. So b would have to be 4 to make that true. All right. 3 and 4 uses a different rule. I see that we're dividing bases and exponents. When I go back and recheck my rule, that tells me I'm going to subtract the exponents. So numerator minus denominator exponent. So for part 3, they both have a base of 4. So we're going to have 4 to the 3 minus 2 exponent. And 3 minus 2 is, of course, 1. So c would have to be 1 so that we'd have 4 to the first power. Number 4, we're going to do the same thing. We're going to have subtraction going on. 8 minus d in our exponent is going to have to equal 5 to the second power, according to our equation. So 8 minus d has to equal 2. If 8 minus d equals 2, d has to equal 6 to make that true. We could also type all these things into the calculator and just show that they're true, but you know, we're doing great, so keep on going. Again, number 5 goes back to the same rules up here, that if we have the same base, we are going to add exponents together. So I would have 6 to the m plus m plus m. You may know that better as 3m. And so if 3m has to equal 21, then 3m, to make that true, m would have to equal 7 to make that true. Number 6 uses a different rule. I see an exponent raised to another exponent. That rule tells us that I'm going to multiply exponents together. So if I have an exponent raised to another exponent, we multiply. So 7 to the 4n has to equal 7 to the 20th. Same base, so 4n has to equal 20. N would have to equal 5. Seven looks a little different. Notice that it's got different bases. It's got a 2 and a 3. So 2 different bases. Watch out for that. And in 8, I don't know the other base. So I'm going to look for a rule where I have 2 different bases. And it's this last one down here, that if we have 2 different bases to the same exponent, we can multiply those bases together first and bring it up to that same exponent. So this is saying 2 times 3 raised to the exponent of 4 equals 6 to the exponent of s. It's unknown. Of course, 2 times 3 equals 6 to the 4th. So 6 to the 4th equals 6 to the s. S has to equal 4. And last but not least, number 8, that same kind of rule, that different bases multiplied together, as long as they're the same exponent, these both have an exponent of 3, we can multiply them together first and then raise them up to a different exponent. You may also notice that we can do any of these rules backwards too. So distributing that exponent, as long as the things inside are multiplying, would bring us back to this 5 to the 3rd times t to the 3rd. So just a good thing to know. They all work forward and backward. Anyway, 5t has to equal 50. T has to equal 10. So a good refresh there about powers and exponents, how we can combine them, how we can work through them together. One of our rules tells us that anything to the power of 0 equals 1. And a lot of students struggle with like, why is that true? How can we prove that? And so 1.3 is a way that we can prove that using one of our other rules that we have. So I see we're going to do some division here. And when we're dividing exponents of the same base, we use subtraction. So I'm going to start with that one rule that people accept a lot more. And we're going to fill in what we have going on here. So to find that power of 2 here, this would be like 2 times 2 times 2 times 2 times 2. There's 5 2's multiplying together. And we're dividing it by 2 to the first power, 1, 2. So maybe you see that they would cancel one of those 2's out. So that's why we have 2 to the 5 minus 1, because 1, 2 cancels out from the 5. We're left with 2 to the 4th, and that does equal 16 if you type it in on your calculator. Calculator use, just hitting a little refresh on this just in case. You could use that too. And it's this caret button right here underneath the clear. That caret button above divide and below clear will bring us to any exponent that we need. So it's a good thing to know. Our next row down, we'd have 5 minus 2. 5 minus 2 is, of course, 3, which means we just have 2 times 2, which is 4 times a third 2, and 4 times 2 is 8. I'm just going to keep on filling this out all the way down. And I'm noticing another pattern going on here too. I'm noticing that each time our value is dividing by 2. And that makes sense. I mean, if we're multiplying by 1 less 2, we can see how, 2 to the first is this. We multiply it by a second 2, we get 4. 4 times a third 2 gets us 8. 8 times a fourth 2 gets us 16. So that might also help in explaining what's going on here. Now here's that one that we're going to get a 0. So when we have 2 to the 5 minus 5 equals 2 to the 0 power. We also know this other separate rule in math, that anything divided by itself equals 1, right? If we have 8 over 8, it equals 1. 57 divided by 57 is 1. X divided by X is 1. So we have the same thing here. 2 to the 5th divided by 2 to the 5th. Here's another reason why it equals 1. It's the same in the numerator and denominator. We can rewrite it like that and use the subtraction rule. Or we can also keep up with our same pattern of what's going on here. If we divide it by another 2, we get 1. And then we can also prove some other rules that we have, something like 5 minus 6 that's going to give us a negative exponent. On a calculator, it'll tell you that the 2 to the negative 1 power is a half. And that also still follows our pattern down here that if we divide by 2 again, we get a half. And divide by 2 again, we're going to get a quarter. So 2 to the 5 minus 7 is a 2 to the negative 2. Here's what a negative exponent does. It's another rule on our list. A negative exponent pushes it down to a denominator of a fraction and turns that exponent positive. Now, this is a rule that a lot of students struggle with. A lot of them think that it's going to give us a negative value. So this might be a good one, that a negative exponent, put this in here, a negative exponent is going to convert it to a fraction. That's a good thing to know. Not a negative answer. It converts it into a fraction. So a couple of other follow-ups that we have going on, the value of 5 to the 0 power, well, that would still be 1, always equals 1. That's one of our rules that we have there. So anything to the 0 power is 1. Our value of 3 to the negative 1, well, that's going to take that 3 and it's going to push it down to a denominator of a fraction and turn the exponent positive. That's what a negative exponent does. So that's just 1/3. And another example of 7 to the negative third power, again, it's going to push it down to a denominator, make that exponent positive, and now I'd have to know what 7 to the third power is. My calculator tells me it's 343, so I trust that calculator. Now we're going to use this in just a second. Oh, I guess a later lesson, so keep that in mind. Alrighty. Our last part that we have here, section 1.4, asks us to sort expressions that are equal into groups, and some may not have a match and some have more than one match, so we should be ready to think about what that might be. All right, so I'm going to have some different values here. Our first quiz that we have is really just rewriting some of these things into other equivalent ways. So we're going to rewrite these in a couple different ways and then see which ones we can group together. Okay, so I'm going to start with the very first one. 2 to the negative 4. Oh, this might be an interesting one to start with, but that's okay. 2 to the negative 4. Remember, a negative exponent converts something to a fraction. So I'm going to put it like this, 1 over 2 to the 4th power. Well, I'm going to stop right there because I notice that that makes this one equal to this one. So these two must be pairs because I just rewrote it like this. So these two have to be the same value. And when I think about what 2 to the 4th power is, 2 times 2 is 4, times another 2 is 8, 8 times another 2 is 16. All right, so one of my values that I'm going to be finding a couple times over here is going to be 1/16. So I'm going to make a list here down at the bottom of things that equal 1/16. And one thing that equals that is this 2 to the negative 4 and 1 over 2 to the positive 4. So they're asking to kind of go back and think about which ones are equal to each other. So those two are equal. Let's keep on going. Now this one is a negative 2 to the 4th power. This is a good time to talk about making very sure we type things in correctly on our calculator. This is saying that we want to do, okay, think about PEMDAS, order of operations. It tells us we're going to do parentheses first, but this has no parentheses. So the next thing that we do is an exponent. This exponent of 4 only applies to what's exactly before it. And the only thing that's directly before it without parentheses, if we do it without parentheses, is 2 to the 4th power. And then we're going to turn it negative. Now I'm making a big deal about this because on our calculator, if we type it in just like they gave it to us, -2, raise it up to the 4th power, we're going to get a -16 out of it. Now this is very different than if we had -2 in parentheses and raised that to the 4th power. So I want you to be careful here because that'll give us a +16. All right, so you have to be careful. Do you notice how they put this -4 squared and this -4 squared? These two are not the same value. We'll go there next, okay? So it looks like I'm going to have some values that equal a -16. And the first one that we came across was a -2 to the 4th. This is important. A negative value, a negative base, may give us a negative answer. Okay. I'm going to highlight that guy orange because I like color coding. Alrighty, let's go stick with this idea. I'm going to skip ahead to these ones over here because I want to go back to this idea. This is very different. If we have a negative 4 times squared, this means negative 4 times negative 4. And a negative times a negative is, of course, a positive 16. Okay, so be careful about that guy. That's going to start us a whole new category. We're going to have some that are equal to 16, and negative 4 squared, in parentheses squared, is going to be different than negative 4 squared without parentheses. So we get two different answers depending on whether it's in parentheses or not. So please, please, pretty, please keep your eye on that. If it gives us a value here in parentheses or we're using a negative input, make sure you're using parentheses correctly. Okay, so we found another one that equaled a positive 16. That would be, oh, negative 4 squared. I already put that there. Let me put that color green so I remember. And we found another one that's going to be a negative 16, this one that we just showed on the calculator, this negative 4 squared. So I'm going to add that to my list over there. All right, I'm just going to keep on solving some of the rest of these. I'll talk it out loud. We already had 1 over 2 to the 4th here. This one just turns it negative, so it would be a negative 1/16. We don't have that yet in our list of possibilities here, so it looks like I need to add another possibility, negative 1/16. This guy. Four squared means 4 times 4, which is 16. 4 squared is going to go with that guy. 4 to the negative 2, a negative forces something into a fraction. So 1 over 4 to the positive 2, that's 4 squared is 16. So I'm going to add this guy to this list here. Oops. Sorry, 4 to the negative 2 belongs with that list. Those guys are yellow. Negative 4 to the negative 2. Ugh. The negative only applies to the 4. The exponent only applies to the 4. So we have negative 1 over 4 squared. 4 squared is 16. Negative 1/16. We have that here. So a negative 4 to the negative 2 power. Those are just getting circled, I guess. There we go. When I have the same base and two different exponents multiplying together, I add those two. So I have 7 plus negative 3, which is 2 to the 4th. 2 to the 4th. We don't have that anywhere. 2 to the 4th is a positive 16. So this whole term is going to go in my same section all together. I could write it all here. 2 to the 7th times 2 to the negative 3rd. Our next one's got some fractions, so I'm going to subtract those exponents. I have a 2 to the 7th minus a negative 3. Double negative. Double negative makes a positive. This is 2 to the 10th. Now, this does not match any other value. 2 raised to the 10th power is 1,024. This guy, I think, is like a value all his own. This guy's going solo. All right, let's keep on going. If I multiply bases and exponents, I add those exponents. -7 plus 3 is 2 to the -4. I'm going to stop there. I already have 2 to the -4 right here. So that's going to have to equal a 1/16. That's going to go in my yellow pile. And one final problem right here. Keep on running out of room. I'm writing all over. -7 minus -3, double negative makes a positive. 2 to the -7 plus 3 gives us 2 to the -4 and 2 to the -4 right here and right there and right here. 2 to the -4 pushes it down to a denominator. 2 to the 4th. This guy will be over here with the 1/16, the yellow pile. So we are just rewriting in some different ways. Sometimes we're simplifying, sometimes we're combining, adding, subtracting, multiplying, and dividing, all kinds of stuff. So I would tab with a little like post-it note or a sticky note or something like that. I've got these nifty little post-it note flag things. I would tab right there on that page because we're going to keep on coming back to this, and this way you can find it easily in your workbook. Or dog ear it, put a paper clip on it, whatever it is. We're going to keep on coming back to this. Give those practice problems a try.